AI 901 Azure AI Fundamentals Full Course. Complete end-to-end exam training for Microsoft Azure AI and Foundry. Hello, and welcome to this complete AI 901 Azure AI Fundamentals video course. In this course, we will cover the concepts, Azure services, Microsoft Foundry skills, and exam decision patterns you need to understand before taking the AI 901 exam. The goal is not only to memorize terms, but to understand how AI workloads are built and how Azure supports them. We will move from basic AI concepts into generative AI, agents, language, speech, vision, information extraction, responsible AI, endpoints, SDKs, and Foundry projects. By the end, you should be able to recognize what a scenario is asking and choose the most appropriate AI concept or Azure capability. The AI 901 exam is for learners who are beginning their career in AI solution development. You do not need to be an expert machine learning engineer, but you should understand the foundations of AI systems and how Azure helps build them. You should be familiar with basic cloud ideas such as compute, storage, networking, identity, access control, and application endpoints. You should also understand basic Python concepts because the exam includes developer-oriented topics such as SDKs, APIs, client objects, and environment variables. Think of this exam as a bridge between AI theory and practical Azure AI implementation. The exam content can be understood in two major parts. The first part is AI concepts and responsibilities, including AI workloads, machine learning basics, responsible AI, generative AI, natural language processing, speech, computer vision, and information extraction. The second part is implementation with Microsoft Foundry, including models, tools, agents, knowledge, endpoints, playgrounds, SDKs, deployment settings, and service selection. This means you need to know both the concept and the matching Azure capability. For example, when the scenario is about detecting language or redacting personal data, think about Azure Language. When the scenario is about extracting structured fields from invoices, think about Document Intelligence or Content Understanding. Artificial intelligence means building systems that perform tasks normally associated with human intelligence. These tasks can include understanding language, recognizing speech, identifying objects and images, extracting data from forms, generating content, and helping users complete work. AI applications usually depend on models that learn patterns from data and apply those patterns to new inputs. The process of using a trained model on new input is called inference. In exam questions, look for clues such as classify, predict, detect, generate, summarize, transcribe, translate, extract, or identify. Machine learning is one of the main methods used to create AI systems. Instead of writing every rule manually, developers train a model with example data so it can learn patterns. A model trained on labeled fruit images may learn to classify new images as apple, banana, or orange. A model trained on transaction data may learn patterns that suggest fraud. Machine learning is part of AI, but AI is the broader goal of creating systems that appear intelligent. AI applications are usually model-powered, but they also need normal application architecture. They need data storage, identity, network connectivity, monitoring, logging, authentication, user interfaces, and business logic. The model is only one part of the solution. Azure provides the cloud platform services that help developers host, scale, secure, and monitor AI applications. Microsoft Foundry provides a focused platform for developing and operating AI apps and agents on top of Azure. Azure is Microsoft's cloud platform for building and running applications at scale. It provides compute to run applications, storage to keep data, networking to connect services, and identity services to control access. AI solutions often combine multiple Azure services instead of using only one model. For example, an AI chatbot may use a Foundry model, Azure Storage, Azure AI Search, Microsoft Entra ID, Key Vault, and monitoring. For AI 901, remember that Azure provides the foundation and Foundry provides specialized AI development capabilities. Azure resources are organized using tenants, subscriptions, resource groups, and resources. A tenant represents an organization's identity boundary in Microsoft Cloud Services. A subscription is commonly tied to billing, quotas, and access boundaries. A resource group is a logical container for related services such as a web app, storage account, and Foundry resource. A resource is the actual service instance, such as a Foundry resource, database, storage account, or AI service. The Azure portal is the browser-based interface used to create, configure, monitor, and manage Azure resources. You can use it to create resources, view costs, check health, manage identities, configure permissions, and access specialized services. You can also create resources programmatically using Azure CLI, templates, scripts, SDKs, or infrastructure automation. Programmatic deployment helps repeat the same setup reliably across development, testing, and production. For exam scenarios, remember that portal and code-based management are both valid approaches. Security is a core part of every AI solution. Azure provides identity, role-based access control, network isolation, secret management, monitoring, and compliance controls. Microsoft Entra ID helps authenticate users and services. Azure Key Vault helps store secrets such as API keys and connection strings. A secure AI application should avoid placing secrets directly in source code or public repositories. A client application is the program that users interact with or that systems run to call AI services. The client can be a web app, mobile app, command line tool, desktop application, or backend service. It collects input, formats a request, authenticates to an endpoint, and displays or processes the response. The model or AI service usually runs on the server side in Azure. This client-server pattern appears often in Foundry and SDK questions. An endpoint is the network address where an application sends requests to a deployed cloud service. In AI solutions, endpoints are used to call deployed models, Foundry projects, Azure Language, Azure Speech, Content Understanding, and other services. A request usually includes headers for authentication and content type, plus a body containing input data. The response often returns JSON with generated text, extracted fields, predictions, confidence scores, or metadata. Endpoint plus credential is a key exam pattern. Microsoft Foundry is a unified platform for building, testing, deploying, evaluating, and managing AI applications and agents. It includes access to model catalogs, playgrounds, deployments, agents, tools, knowledge, evaluation, monitoring, and governance. A Foundry resource provides the Azure platform capabilities. A Foundry project is a workspace where you organize models, agents, datasets, evaluations, files, connections, vector indexes, and settings. This distinction between resource and project is important for exam questions. The Foundry Model Catalog helps developers discover and compare models. It can include Microsoft models, partner models, open source models, small language models, embedding models, multimodal models, coding models, and domain-specific models. You can evaluate models based on capability, latency, cost, quality, safety, licensing, context length, and deployment options. The best model depends on the use case. A high reasoning model may be useful for complex planning, while a smaller model may be better for cost-sensitive or low-latency workloads. A foundation model is a large pre-trained model that provides general capabilities out of the box. It can often be used immediately for tasks such as chat, summarization, drafting, reasoning, classification, and question answering. Some foundation models can also be customized or fine-tuned for specific needs. The exam may contrast foundation models with task-specific models. Remember that foundation models are general starting points, not automatically perfect solutions for every business problem. Model evaluation helps you choose and validate the right model. Foundry can help compare models using benchmarks, leaderboards, playground testing, and evaluation metrics. Traditional metrics can include accuracy, precision, recall, and F1. AI-assisted metrics can include groundedness, relevance, coherence, fluency, and similarity to expected answers. Evaluators can detect and score quality or safety issues, but detection alone does not automatically fix the issue. Deploying a model means making it available as a secure service that applications can call. Deployment usually creates an endpoint and applies configurations such as model version, throughput, region, and safety settings. Deployment also activates monitoring, logging, usage tracking, and operational controls. In Foundry, deployment choices affect cost, performance, scalability, and governance. In exam scenarios, deployment is the step that turns a model selection into something application code can use. Rate limits and quotas are important in AI deployments. Tokens per minute, requests per minute, and capacity settings can affect how much traffic a deployment can handle. A token is a small unit of text or data processed by a generative AI model. Larger prompts and longer responses consume more tokens. If traffic exceeds limits, the service may throttle requests to protect stability. The Foundry Playground is used to test models before writing full application code. You can try prompts, adjust system instructions, compare outputs, configure parameters, and view sample code. Playground settings such as temperature, maximum output tokens, and system instructions can later be reused in code. This makes the playground a bridge between experimentation and application development. For exam questions, the playground is useful for validating behavior before building a client application. Temperature controls how creative or deterministic a model response may be. A lower temperature usually makes responses more consistent and focused. A higher temperature can make responses more varied and creative. Maximum output tokens control the maximum length of the generated response and can affect cost and throttling. System instructions define the model's behavior, role, tone, constraints, and guardrails. Responsible AI is one of the most important AI 901 topics. Responsible AI means designing and operating AI systems in ways that reduce harm and support trust. The key principles include fairness, reliability and safety, privacy and security, inclusiveness, transparency, and accountability. These principles apply to both traditional AI and generative AI. For the exam, responsible AI is not a final step. It should guide the full life cycle from design to monitoring. Fairness means an AI system should not produce unfair outcomes for people based on irrelevant characteristics. Bias can enter through training data, labels, feature choices, evaluation data, or deployment context. A hiring system should not unfairly disadvantage applicants because of demographic factors unrelated to job performance. A college admission system should be tested to ensure relevant criteria are used fairly. In exam scenarios, fairness is usually connected to bias, discrimination, and equal treatment. Reliability and safety mean an AI system should behave as expected and avoid unacceptable harm. AI models can make mistakes because outputs are based on probabilities, not guaranteed truth. Safety controls may include confidence thresholds, human review, fallback responses, testing, monitoring, and guardrails. A robot using object detection should avoid physical action when confidence is too low. A generative AI assistant should avoid harmful instructions and risky automated actions. Privacy and security mean the system must protect data, identities, secrets, models, and outputs. AI applications may process personal information, health data, financial data, voice recordings, images, or internal documents. Developers must protect data during storage, transmission, processing, and access. Techniques include encryption, access control, private networking, secret management, data retention controls, and PII redaction. In exam scenarios, privacy and security are connected to protecting sensitive information. Inclusiveness means AI should be useful to people with different needs, abilities, languages, and contexts. A speech-based assistant should also support captions or text for users who cannot hear. A visual application should provide alternatives for users who cannot see images. Applications should consider language support, accessibility, and different user environments. Inclusiveness is both a responsible AI principle and a practical design requirement. Transparency means users should know when AI is being used and understand important limitations. An AI system should not pretend its output is always correct or human written if that would mislead users. Transparency may include explanations, citations, confidence scores, documentation, user notices, and disclosure that AI is involved. In high-impact scenarios, users may need to know what data influence a decision. For the exam, transparency often means disclosure, explainability, and clear communication. Accountability means people and organizations remain responsible for AI systems and their outcomes. A company cannot avoid responsibility by saying the model made the decision. Accountability requires governance, ownership, audit trails, review processes, risk management, and monitoring. Human oversight is especially important when AI affects safety, finances, employment, education, healthcare, or legal outcomes. In exam questions, accountability is usually connected to governance and responsibility. Generative AI creates new content in response to prompts. It can generate text, code, summaries, explanations, images, audio, video, and structured output. Generative AI is commonly powered by large language models or multimodal models. A prompt is the user input or instruction, and a completion is the generated result. The key exam point is that generative AI creates original responses based on learned patterns and provided context. Large language models are trained to process and generate language. They learn relationships between words, phrases, concepts, and patterns from large text collections. Small language models may be more efficient for focused tasks, edge scenarios, or cost-sensitive applications. LLMs are strong for chat, summarization, drafting, reasoning, question answering, and code assistance. Model choice should reflect task complexity, cost, speed, safety, and deployment needs. Tokenization breaks text into smaller units called tokens. A token can be a word, part of a word, punctuation mark, or other character sequence. Models process token IDs rather than raw human language. Token count affects cost, performance, maximal context, and throughput. When a prompt is long or the answer is long, the request consumes more tokens. Embeddings are numeric vector representations of meaning. A vector is a list of numbers that allows the system to compare text, images, or other content mathematically. Similar meanings usually have similar vector directions. Embeddings are useful for semantic search, recommendations, clustering, retrieval, and drop. In exam terms, embeddings help systems compare meaning rather than only exact words. Transformers are a core architecture behind modern generative AI. A transformer uses attention to evaluate relationships between tokens in context. Attention helps the model decide which parts of the input matter most when producing an output. This is why the same word can mean different things depending on surrounding words. AI 901 does not require deep math, but you should understand that attention helps models process context. Prompts are the instructions or inputs sent to a generative AI model. A good prompt is clear, specific, and includes a desired audience, format, context, and constraints. A vague prompt often produces a vague response. A strong prompt might ask the model to summarize a document for a beginner in 5 bullet points with no jargon. Prompt design is a practical skill because prompt quality affects response quality. System prompts and user prompts serve different purposes. A system prompt defines the assistant's role, tone, restrictions, and behavior. A user prompt provides a specific task or question. For example, the system prompt may say the model is a helpful tutor that explains step by step, while the user prompt asks for an explanation of speech synthesis. The model responds to the user while following the system instructions. Conversation history helps generative AI applications maintain context across multiple turns. Without history, each question may be treated as isolated. With history, the model can understand follow-up questions and references to earlier messages. Applications may include full history, summarized history, or only selected relevant context. History improves continuity, but can increase token usage and privacy risk. Retrieval augmented generation, or RAG, improves responses by adding retrieved information to the model prompt. A RAG system searches trusted data sources such as documents, indexes, databases, or knowledge bases. The retrieved content is used to ground the model's response. This is useful when answers must come from company policies, product manuals, legal documents, or current internal knowledge. In Foundry, knowledge sources and indexes support grounded agents and applications. AI agents are applications that can reason over input, use instructions, call tools, and perform tasks for users. An agent includes a model, system instructions, and optional tools or knowledge sources. The model provides language understanding and reasoning. The instructions define what the agent is supposed to do and how it should behave. The tools allow the agent to take action or retrieve information. Tools give agents capabilities beyond conversation. Knowledge tools can search documents, indexes, databases, or websites. Action tools can call APIs, run functions, execute code, create records, send messages, or trigger workflows. Tools must be governed carefully because they can affect real systems. In AI 901, remember that agents combine model reasoning with tool use. Knowledge gives an agent trusted context. A model on its own may answer generally, but a knowledge-connected agent can answer from approved content. Knowledge sources can include documents, datasets, storage locations, internal sites, or search indexes. Grounded answers can include citations or references to the source content. This improves accuracy, traceability, and enterprise trust. Multi-agent systems use more than one agent to complete complex tasks. One agent may collect information, another may analyze it, and another may write the final response or take action. This pattern is useful when different agents have different roles or tools. Multi-agent systems need orchestration, clear responsibilities, and safety boundaries. For exam purposes, understand that agentic AI can involve coordinated agents, not only one chatbot. Foundry agents can be created and tested in the portal. You select a model, write instructions, add tools, connect knowledge if needed, and test the behavior in the playground. Once the agent works as expected, it can be published and used by applications. A published agent becomes a reusable component with a stable way to call it. This helps teams use consistent behavior across multiple apps. The Foundry Project API allows applications to call agents programmatically. A developer can connect to a Foundry project, reference an existing agent, send input, and receive output. This lets agents be integrated into web apps, bots, backend workflows, and business systems. Agent IDs, project endpoints, and authentication are important implementation details. In exam questions, calling an agent is different from calling a raw model deployment directly. Natural language processing, or NLP, focuses on analyzing and understanding human language. NLP workloads include language detection, key phrase extraction, entity recognition, PII detection, sentiment analysis, classification, summarization, and translation. NLP can be performed by general-purpose generative models or by purpose-built tools. General-purpose models are flexible, while purpose-built tools often return more predictable, structured output. Azure Language is the key service to remember for many text analysis scenarios. Tokenization is also important in traditional NLP. It breaks text into smaller units so the system can analyze it. Text normalization can standardize case, remove punctuation, or clean content. Stop word removal can remove common words that add little value for some statistical tasks. However, per-processing choices can affect meaning, so they should match the task. N-grams are sequences of one or more words. A unigram is one word, a bigram is two words, and a trigram is three words. N-grams help systems recognize meaningful phrases such as artificial intelligence, cloud computing, or customer support. Stemming reduces words to root-like forms, while lemmatization reduces words to valid dictionary forms. Part of speech tagging identifies grammatical roles such as noun, verb, adjective, or adverb. Frequency analysis counts how often terms appear in text. High-frequency terms can reveal the main subject of a document. TF-IDF improves on simple frequency by identifying words that are important in one document but less common across a collection. This helps separate general words from distinctive terms. These statistical techniques are older than generative AI but still useful for understanding text analysis. Bag of words represents text as word counts or word occurrences. It ignores word order but can still support classification tasks. For example, spam detection may learn that certain phrases occur often in spam messages. Sentiment classification may learn patterns associated with positive or negative reviews. The exam expects conceptual understanding rather than detailed algorithm implementation. Text summarization can be extractive or abstractive. Extractive summarization selects important sentences directly from the original text. Abstractive summarization generates new wording that captures the meaning of the source. Generative AI commonly supports abstractive summarization. In exam questions, summarization means reducing text while preserving the main ideas. Entity recognition identifies specific things mentioned in text. Entities can include people, organizations, locations, dates, times, quantities, percentages, email addresses, phone numbers, and product names. Entity recognition turns unstructured text into structured information. For example, a meeting transcript can be analyzed to find names, dates, organizations, and action-related details. In exam scenarios, choose entity recognition when the requirement is to identify named items in text. Language detection identifies the language of a text input. It can return a language name, code, and confidence score. This is useful in support systems, document routing, translation workflows, and global applications. For example, a customer message can be routed to the correct language team. Azure Language is a strong fit for this type of structured text analysis. PI detection finds sensitive personal information in text. PI can include names, addresses, phone numbers, email addresses, account numbers, and other private details. A system can use PI detection to redact sensitive data before storage or sharing. This supports privacy, compliance, and responsible AI. For AI-901, connect PI detection to Azure Language and the privacy and security principle. Sentiment analysis identifies whether text expresses positive, negative, neutral, or mixed sentiment. Opinion mining can identify sentiment about specific aspects of a product or experience. A review may be positive about food but negative about service. Businesses use sentiment analysis for reviews, surveys, social media, support tickets, and customer feedback. In exam scenarios, look for words such as satisfaction, opinion, emotion, feedback, and review. Azure Language SDK helps developers add structured NLP capabilities to applications. A Python application can create a client object using an endpoint and credential, then call methods such as language detection or PII recognition. SDKs simplify communication with Azure services. They help developers avoid building raw HTTP calls from scratch. Use Azure Language SDK when the application needs predictable structured text analysis. General-purpose AI models can also perform text analysis through prompts. They can summarize text, classify it, extract entities, explain meaning, translate content, or answer questions. This is useful when the task is flexible or conversational. However, results may vary because generative models are probabilistic. When the same input must return consistent structured fields, a purpose-built service may be better. The Model Context Protocol, or MCP, provides a standard way for agents to connect to external tools and data sources. An MCP client is usually the agent or host application. An MCP server exposes tools, data, or actions in a standard format. Azure Language capabilities can be exposed to an agent through an MCP server. This lets agents combine flexible reasoning with deterministic language tools. Speech AI enables applications to listen and speak. Speech recognition converts spoken audio into text. Speech synthesis converts text into spoken audio. Together, these capabilities support voice assistants, call transcription, captions, accessibility, dictation, language learning, and conversational agents. Azure Speech in Foundry tools is the key Azure capability for speech workloads. Speech recognition is also called speech to text. It can transcribe microphone input, audio files, recorded calls, or live streams. The system processes sound waves, extracts audio features, predicts phonemes, applies language modeling, and returns text. Accuracy depends on audio quality, background noise, microphone placement, accent, language, and domain vocabulary. In exam questions, choose speech to text when spoken audio must become written text. Speech synthesis is also called text to speech. It converts written text into natural sounding audio. The system normalizes text, determines pronunciation, predicts rhythm and emphasis, and generates an audio waveform. Neural voices can make output sound more expressive and human-like. In exam questions, choose text-to-speech when an application needs to read information aloud. Prosody is the rhythm, pitch, emphasis, pauses, and tone of speech. Good prosody makes synthesized speech sound natural instead of robotic. The same sentence can communicate different meaning depending on which word is emphasized. Text-to-speech systems use punctuation, context, and model predictions to choose natural speech patterns. Prosody is important for accessibility, conversational agents, training, and media. Azure Speech SDKs help developers integrate speech into applications. A speech-to-text client can capture or send audio and receive transcription results. A text-to-speech client can send text, choose a voice, and generate audio output. SDKs handle authentication, endpoint communication, and service interaction. For AI-901, know why SDKs are used and what capability they provide. Voice Live combines speech recognition, AI reasoning, and speech synthesis into a real-time voice experience. It helps developers build conversational agents that can listen, process, and speak back naturally. This reduces the need to manually stitch separate services together for real-time voice interaction. It is useful for voice assistants, call center agents, accessibility experiences, and hands-free applications. In exam scenarios, Voice Live is about real-time spoken conversation with an AI agent. Computer vision is AI for interpreting visual information. It can analyze images, videos, screenshots, documents, camera feeds, and visual scenes. Common tasks include image classification, object detection, semantic segmentation, OCR, captioning, visual question answering, and image generation. Computer vision supports manufacturing quality checks, medical imaging, retail monitoring, autonomous vehicles, and accessibility tools. In AI 901, vision questions often ask what kind of visual task is being performed. A digital image is made of pixels. Each pixel stores numeric values representing brightness or color. A grayscale image may use one value per pixel, while a color image usually uses red, green, and blue channels. Computer vision models analyze these numeric values to find patterns. The key idea is that computers process images as numbers, not as human visual experiences. Image classification predicts the main category or label of an image. Object detection identifies multiple objects and their locations using bounding boxes. Semantic segmentation classifies individual pixels to show precise object regions. Image captioning, or contextual image analysis, describes what is happening in an image. Exam questions often depend on distinguishing these tasks from each other. Filters are used in image processing to transform pixel values. A filter kernel moves across an image and calculates new pixel values based on neighboring pixels. Some filters detect edges, while others blur, sharpen, or enhance images. Convolutional neural networks learn filters automatically during training. This is why CNNs are strongly connected to image feature extraction. A convolutional neural network, or CNN, is a deep learning architecture commonly used for image analysis. CNNs use convolutional layers to extract visual features such as edges, textures, shapes, and patterns. These feature maps are then processed by the model to produce predictions. CNNs are useful for classification, detection, and many traditional vision tasks. For AI 901, remember that CNNs use filters to extract numeric features from images. Vision transformers apply transformer ideas to images. Instead of processing words as tokens, they divide images into patches and process those patches. Attention helps the model understand relationships between different regions of the image. This improves contextual understanding across the full image. Vision transformers are important for modern multimodal AI. Multimodal models work with more than one input type. A multimodal model may process text and images together in a single request. A user can upload an image and ask what objects are visible, what is happening, or what text appears. The model combines visual understanding with language reasoning. In Foundry, multimodal models can be tested in the playground and called from applications. Image generation creates new images from text prompts or other inputs. A user can describe a desired scene, object, style, or concept, and the model generates visual output. Many modern systems use diffusion-like approaches that gradually form an image from noise. Image generation is different from image analysis because the system creates new visual content instead of interpreting existing content. Use cases include design, marketing, education, prototyping, and creative workflows. Video generation creates video content from prompts or input assets. Video generation is more resource-intensive than text or image generation. It may run as an asynchronous job, where the request is submitted and results are retrieved later. The system must consider visual consistency, motion, timing, and scene progression. In exam questions, remember that long-running media generation may require polling or asynchronous processing. Information extraction converts unstructured content into structured data. It is used for receipts, invoices, tax forms, contracts, identity documents, shipping records, claims, scanned archives, and business forms. The system may use OCR to detect text and then map the text to meaningful fields. Extracted data can be stored in databases, searched, reviewed, or sent to workflows. In AI 901, choose information extraction when content must become structured machine-readable fields. OCR stands for Optical Character Recognition. OCR converts text visible in images, scans, screenshots, or PDFs into machine-readable text. OCR can process scanned invoices, photographed documents, forms, receipts, and handwritten notes. A typical OCR pipeline includes image input, pre-processing, text region detection, character recognition, and output cleanup. OCR tells you what text exists, but it does not always understand what each field means. Field extraction maps OCR output to business fields. For example, an invoice may contain vendor name, invoice number, date, tax, line items, total, and payment terms. A receipt may contain merchant, purchase date, subtotal, tax, and total. Field extraction can use templates, layout analysis, machine learning, semantic models, or generative AI. The key exam distinction is that OCR extracts text, while field extraction maps text to structured meaning. Azure Document Intelligence supports document processing scenarios. It can help extract text, tables, key value pairs, and fields from forms and business documents. It reduces the need to build OCR and document extraction pipelines from scratch. It is useful for invoices, receipts, forms, identity documents, and custom document extraction. In exam scenarios, choose Document Intelligence when the task is document analysis and structured extraction. Azure Content Understanding extracts structured information from multiple content types. It can work with documents, images, audio, and video, depending on the analyzer and scenario. An analyzer defines how content is processed and what structured output is returned. Pre-built analyzers can help with common content types, while custom analyzers can support specialized schemas. Content understanding is especially useful when business content exists in many formats. Content understanding often uses asynchronous processing. The client submits content for analysis and receives an operation location or long-running operation handle. The application polls or waits until the analysis completes. When complete, the service returns structured results, often including fields, markdown, transcripts, metadata, and confidence values. This asynchronous pattern is common when processing larger documents, audio files, or videos. Extraction solutions should be planned based on document characteristics and business requirements. Standardized forms may work well with templates or pre-built analyzers. Variable layouts may require machine learning or custom schema-based extraction. High-volume workloads need scalable cloud processing, and high-risk workflows may need human review. Security, privacy, accuracy, latency, and integration requirements all matter. Data normalization improves extracted results before downstream use. Dates may need a consistent format, such as year, month, day. Currency values may need standardized symbols, separators, decimal values, and locale handling. Addresses, phone numbers, names, and IDs may need validation. Normalized data is easier to store, search, compare, report, and use in business workflows. Python is commonly used for lightweight AI client applications. A simple client may load environment variables, create a service client, send input, and print or store the response. Environment variables can hold endpoint URLs, deployment names, keys, and other configuration values outside the source code. SDKs such as OpenAI, Azure AI Projects, Azure Identity, Azure Speech, Azure Text Analytics, and Content Understanding reduce development effort. For AI-901, focus on what the code is doing conceptually. The OpenAI Compatible Responses API can be used to call deployed generative AI models. It can send system instructions, user prompts, model parameters, and sometimes multimodal inputs. The response may include generated text or structured output. This API is useful when an application needs flexible model-generated answers. Use Azure Language or other purpose-built services when predictable, structured analysis is more important. A complete AI application usually combines several services. A chatbot may use a Foundry model for reasoning, Azure AI Search, or knowledge sources for retrieval, Key Vault for secrets, Entra ID for authentication, storage for files, and monitoring for operations. A voice assistant may use speech-to-text, a model or agent, and text-to-speech. A document automation system may use content understanding, validation logic, and a downstream workflow. AI-901 questions often test your ability to choose the right service combination. Monitoring and evaluation are important after deployment. AI systems can fail because of bad input. Changing data, poor prompt, model limitations, latency, cost spikes, or unsafe output. Logs, metrics, evaluations, and user feedback help teams improve the system. Responsible AI monitoring helps detect harmful content, bias, security issues, and quality problems. Production AI is not finished when the model is deployed. It must be operated carefully. The most important exam strategy is to identify the workload first. If the input is written text and the task is sentiment, entities, PII, or language detection, think Azure Language. If the input is audio and the output is text, think speech to text. If the input is text and the output is audio, think text to speech. If the input is an image or video and the task is visual analysis, think computer vision or multimodal models. If the input is a form, invoice, receipt, or business content, and the output is structured fields, think document intelligence or content understanding. The second exam strategy is to identify whether the scenario needs flexible generation or predictable structured output. A general-purpose language model is good for drafting, summarizing, answering questions, and conversational reasoning. A purpose-built tool is better when the output must be consistent, structured, and easy to integrate into a workflow. An agent is better when the solution needs instructions, tools, knowledge, and repeatable task behavior. A raw model is better when the app simply needs inference from a prompt. The third exam strategy is to apply responsible AI to every scenario. If the issue is unfair treatment, choose fairness. If the issue is unsafe behavior or low confidence, choose reliability and safety. If the issue is sensitive data or access control, choose privacy and security. If the issue is accessibility or serving all users, choose inclusiveness. If the issue is disclosure or explainability, choose transparency. If the issue is governance or ownership, choose accountability. Let us close with a final review. AI-901 expects you to understand AI workloads, responsible AI, machine learning foundations, generative AI, agents, NLP, speech, vision, information extraction, and Microsoft Foundry implementation. You should understand Azure resources, endpoints, keys, secrets, SDKs, client applications, model deployment, playground testing, evaluation, quotas, throttling, tools, knowledge, MCP, and content understanding. You do not need to become an advanced data scientist, but you must understand how the pieces fit together. Keep practicing by reading a scenario, identifying the workload, choosing the right service, and applying responsible AI. Thank you for watching this complete AI 901 Azure AI Fundamentals course, and best wishes for your certification exam.